Hello, welcome. This is a video on how to do operations on radicals. When we're adding or subtracting radicals, you can only combine them. You can add whatever you want. You can take the square root of 3 plus the square root of 5. That's fine. You're adding them or subtracting them, as the case may be. But you cannot combine them into a single term, if you will, or single radical in addition or subtraction unless they are like radicals. But sometimes we look at these and we think these can't be combined because none of them are the same radical. But if we simplify them, it turns out that some of them end up being similar radicals to the others or like radicals to the others. So I'm going to take 7 square root of 24. I'm not going to spend a lot of time talking about how to simplify these radicals. If you want to know how to do that, there is a whole section on simplifying radicals, and you can look back at one of those videos. So I'm going to do this in what I find to be like the fastest way. So 7 times, and the square root of 24 has a perfect square as a factor, which is the square root of 4, times the square root of 6. And so this one is there. That's still equal to what it was before. And then I've got minus the square root of 2, and that's just going to stay the same. Minus 3 times the square root of 54, that is the square root of 9 times the square root of 6. Once again, equal to what we had here before. This is the same as what we had there. And then we've got plus the square root of 8. And so this is plus the square root of 4 times the square root of 2. And we see this and is the same as this. So now we're just going to kind of simplify this again. This is 7 times the square root of 4 is 2 times the square root of 6 minus square root of 2 cannot be simplified, so we're just going to leave that there. Then we've got minus 3 times the square root of 9 is 3 times the square root of 6 plus, and then the square root of 4 is 2 times the square root of 2. Just highlight which ones we're talking about for each of these to hopefully draw your attention that they have not changed. They are the same as they were before. Change what they look like, but not change their value any. So 7 times 2 is 14, square root of 6, minus the square root of 2. And then we've got minus 3 times 3 is 9, square root of 6. And then we've got plus 2, square root of 2. Now, just in terms of the colors, that's what I'm going to look at. That and this, all of those green ones, they are the same. So negative 9 square root of 6 is the same as negative 3 square root of 54. I'll pull up a calculator here. It takes a little bit for it to load, so I'll let that be loading while we continue to look at this. So I can show you negative 9 square root of 6. That negative 9 square root of 6 is indeed equal to negative 3 square root of 54. Those values are the same. We've just simplified them. But now that we've simplified them, I'm going to change the colors out here just a little bit so that I can match which ones are like terms. Because this one, 14 rad 6, is now like radical with negative 9 rad 6. And this plus 2 rad 2 is the same then as this minus rad 2. And 14 rad, so I think it's nice to kind of bring them together. 14 square root of 6 minus 9 square root of 6. And then I've got minus square root of 2, and that's the same as minus 1 square root of 2. Most of the time I don't write it, but I am going to write it this time just so you can see how many roots of 2 we're talking about. Minus 1 plus 2 roots of 2. And yeah, I just moved those around. I didn't change anything. This minus 1 root 2 is that same as that minus root 2. And then I've got plus 2 root 2. And then over here I've got 14 square root of 6 and minus 9 square root of 6. I brought them all together. And now I can combine those that are like terms. 14 roots of 6 minus 9 roots of 6, that would be 5 roots of 6. 5 square root of 6, or 5 rad 6. And then I've got minus 1 root 2 plus 2 root 2. If it helps you to put these in a different order, I've got 2 root 2 minus 1 root 2. If I have 2 cats and I take away 1 cat, I have 1 cat. So I would write minus 1 square root of 2. I'm just using cat because it doesn't matter. If I've got 2 of something and I take away 1 of something, I'm going to be left with just 1 of something. And most of the time, we're not even going to write that 1 because it's understood. And it's simpler to write just root 2 rather than 1 root 2. So we always want to simplify it if we can. And so this is our final answer because on the one hand, we have square roots of 6, and on the other hand, we have square roots of 2, so we cannot combine them because they're not like radicals. So we get to this point, we're done. Now, just like I'm going to show you here in a second that, that this is true, that negative 9 root 6 is equal to negative 3 root 54. You could, in fact, do the same thing with this whole expression. Plug that into your calculator and show that it is also equal to that. So if you're looking for a check, like you're doing a test, you want to know, do I have this right? You could literally plug this in and you could show that it's equal to that. The thing you want to be careful about is just assuming that because they're equal, that you have the right answer. You might have something along the way, like this would also be equal to this up here. Those would be equal, but this is not completely simplified. And so this would not give you full points on a test, but this would. Okay, so negative 9 root 6. So I'm going to put negative 9 square root of 6. Just show that's that value. And then negative 3 root 54. So negative 3 times the square root of 54. And it gives us the same value. Those are equal values. So there you go. Got this. Keep working hard.